Hey John, how's it going? So I made a mistake on the note sheet that I gave you. It said that there were only 4 parts to this chapter. It said that there was only law of cosines, the area of a triangle, law of sines, and the ambiguous case. But there's actually another one called forces and vectors. Say hi to my cat. He wants to know what's going on. Okay. Forces and vectors. So this is the last section that we have to do for this chapter. It's not going to take that long, and then that's it for chapter 14. Okay? So let's see. Whenever you have a question that's dealing with forces and vectors, what you're going to do is draw a parallelogram, and I'm going to explain to you why. But the first thing that you want to do with questions like this is always to draw a parallelogram. And the reason for that is this. We have, for the questions that we're going to deal with, there's going to be 2 different applied forces. Applied force 1, that is the smaller force, and applied force 2, which is the bigger force. You can kind of think of this as pretend that you and I are pulling on something. Pretend that you and I are pulling on a toy or whatever. So the toy is right here in the middle. Parker, no, you can't be on the computer. 65, okay. Alright. Pretend that that toy is right here in the middle of us. And I am pulling on the toy this direction, and you are pulling on the toy in this direction. And, sorry, excuse me. Let's just pretend that, you know, you're stronger than me, so your force is greater than my force. And then, all of a sudden, we both let go, both at the exact same time, we let go of this toy or whatever it is. And the resultant force is where the toy would fly. So you're not really going to have to deal with this stuff more until you get into, like, physics. But it's pretty much when you're pulling on something this way and this way, and if you let go at the same time, it's going to kind of fly right in between those 2 forces. Okay, so the reason why I told you to draw a parallelogram is because you have an applied force, number 1, applied force number 2, and then you have the resultant force. And if you connect these like this, it creates a parallelogram. So what we tell students when you're dealing with questions like this, just draw a parallelogram right to begin with, draw a line right down the middle of it, and that's going to be called the resultant force. The thing that's important to remember is that the resultant force does not bisect the angle between those 2 forces. So let me explain what that means. I have a parallelogram right here, and my resultant force is the line that goes right down this diagonal. That diagonal does not bisect this angle. So this angle right here might be 40 degrees. That does not mean that this is 40. This could be 20. This could be 35. But it does not bisect this angle. And when I say bisect, I mean divide it in half. Unless the 2 forces are equal. And what do I mean by that? You will, on the test, have one question, and I'm kind of giving you a heads up. One question in which you're not dealing with a parallelogram, you're going to actually draw a rhombus instead. And a rhombus is the same thing as a parallelogram, except for all 4 sides are equal. So the question that you're going to see on the test like that, it says, force 1 is 20 pounds and force 2 is 20 pounds. So you're not dealing with a parallelogram anymore, because in a parallelogram, this side is greater than that side. So if you're dealing with a rhombus like this, then that diagonal, that resultant force, it does bisect that angle right in half. So those 2 angles would be the same. So that's just like a little bit of a heads up for the test that you're going to take. If it's a parallelogram like this, that angle does not bisect. If it's a rhombus, the line does bisect. Okay? Let me show you what I mean. We're going to do a lot of different word problems with these kind of questions with forces and vectors. Okay? Let's see the first one. 2 forces of 28 pounds and 41 pounds act on a body. Okay, so as soon as you see the word 2 forces, you're going to automatically draw a parallelogram. Now, the good part about this part of the chapter is that you don't have to deal with any new information. Actually, all of the stuff that all the equations that you're going to deal with for forces and vectors, you're still using the exact same equations as before. You're still dealing with area of a triangle, law of cosines, and law of sines. So that stuff didn't change at all. You're still only going to be using those equations. It's just that you're dealing with them in a parallelogram instead of a triangle. So two forces of 28 pounds and 41 pounds. So I'm going to draw my parallelogram. I'm going to draw the resultant force right down the middle, and then I'm going to label my drawing. So you always put the smaller force right here. So this is a force of 28 pounds, and this is a force of 41 pounds. Act on a body so that the angle between the two forces, meaning that this whole angle, not the angle between here and here or here and here, this whole thing is 72 degrees. Find to the nearest tenth of a pound the magnitude of the resultant force. All it wants you to do is find the length of the resultant force. It says magnitude, and that's just because we're dealing with quote-unquote forces. So this is 28 pounds, this is 41 pounds. It wants to know how many pounds the resultant force is, but it uses the word magnitude, but don't let that confuse you. So here's what is cool about a parallelogram. We know a lot of stuff about a parallelogram already. Remember from yesterday or the other videos that I did, remember how this side is equal to that side. So if I know this side's 28, then this side is 28 as well. And that side is 41 as well. The other thing that we know is that this angle and that angle are supplementary, meaning that they add up to 180 degrees. And I think I showed you that the other day by showing you that whatever angle this is, if I like kind of picked that up and brought it over here, you see how this angle and that angle add up to be 180 degrees, so they're supplementary. Okay, so because they're supplementary, meaning that they add up to 180 degrees, I know that if this one is 72 degrees, then this must be 100, whoops, how did I get yellow? This must be 108 degrees. Okay, so we already know a lot about this parallelogram, and what we're trying to figure out, we are trying to figure out the magnitude of the resultant force. We're trying to figure out how long that thing is. Well, I know that we are dealing with a parallelogram right now, but the best part about a parallelogram is that a parallelogram is really two triangles put together. And actually, that triangle right there is congruent to this triangle below it. So if I'm just looking at this triangle right here, I know two side lengths and I know one angle. So which equation am I going to use? I'm not going to use area of a triangle because I'm not given any information about area. The law of sines, in order to use law of sines, we would need to know what either that angle was or what that angle was, because law of sines uses at least two angles, so that doesn't really make any sense. So I'm going to come over here, take a look at my law of cosines. Law of cosines, you have to have side, angle, side, or side, side, side. And we do have side, angle, side. So we can use law of cosines. Now remember, the only important part about law of cosines is whatever angle you're using in the equation, the side across from it has to come first. So because we're using angle 108, this side, the resultant force, is what we're going to have to write in our equation first. So let's do that. Let's write x squared is equal to, now it doesn't matter which other side you use first, so I'm going to do 41 squared plus 28 squared minus 2 times 41 times 28 cosine of 108. Now, these are my favorite kind of questions because we're solving for x squared, and all we have to do is type all of that stuff into our calculator, which is awesome. So let's do that. 41 squared plus 28 squared minus, I always put these in parentheses, 2 times 41 times the cosine of 108 Let me just make sure that I'm in degrees, and I am. So then I can hit enter. X squared is equal to 2,490.339. So if that's what x squared is, what is x, Parker? No. What's x equal to? I can just take the square root of that. X is equal to 49.9 pounds. And it said to the nearest tenth of a pound, so there you go, 49.9. That is my answer. So it's really not that bad. The whole concept about forces is you're dealing with a parallelogram, but within a parallelogram you have triangles. So you're still using all the equations that we've talked about before, and it's still the exact same thing. Let's try to do one more question. Okay, so two applied forces. Stop. I'm going to draw something. I'm going to draw a parallelogram really quick. Two applied forces produce a resultant force of 18.6 pounds. So this time the resultant is 18.6, and we call it resultant because, like I said, if we were fighting over something and we let go, the result would be it would fly in that direction. The smaller force measures 15.8, so we put it on the smaller side of the parallelogram. The larger force is 24.3. Find the measure of the angle between the two forces to the nearest tenth of a degree. Okay, so this time it gave us all those sides, and we have to figure out what this angle is. Well, like I said before, the whole concept of dealing with a parallelogram is really just to deal with the triangles inside of the parallelogram. So what I'm going to do is I'm going to rewrite 15.8 over here. And if you want to, you could always just highlight this triangle so that you know that you're only focusing on that triangle right there. Now, we just said that our goal is to figure out what this angle is. But if I know that this angle is supplementary to that angle right here, and I have that triangle, why don't I figure out what this angle is equal to? Because I have all the information for that triangle, and then I can just do 180 minus that answer to figure out what it is over here. So this time, if I have all of the sides of a triangle, I'm certainly not going to use law of sines because you need to know a lot about the angles. So I'm going to use the law of cosines again. So this time, we are looking for this angle, so I'm going to use the side that's across from it in my equation first. Remember, that's the hardest part about that, is remembering to write that angle or that side first. So this is 18.6 squared is equal to 15.8 squared plus 24.3 squared minus 2 times 15.8 times 24.3 times the cosine of x, and that's what we're solving for. And I'm going to stop this and start another video.